sklearn has an ordinal encoder class that can do this for us automatically. And the syntax is the same as it was for label encoding. I now have an ord encoded df, which is a data frame that has ordinal encoded the data from my original data frame. Now I have lost interpretability here. When I see a 2 in cap surface, I don't know what that originally represented. So there are ways to work around that, but that is a potential issue. You'll notice perhaps that the encoding used by the program was not the same as my encoding. So sklearn's label encoder put 2 on the first capped surface value, whereas I put 0. So the replacement values used by this are arbitrary. They don't necessarily happen in the same order as the ones that you might create. Often students will prefer ordinal encoding to one-hot encoding. You might find it easier to understand. There's a big warning. Ordinal encoding is appropriate only if your data is ordered in some way. Machine learning algorithms are going to look for trends in the data. If you replace values with numbers, there's a chance the algorithm will capture a trend in the original number that isn't there. This is especially true for linear models like logistic regression and support vector machines. Suppose that some university has 4 dorms. Their names are James, Johnson, Jackson, and Juergens. Let's say that we did ordinal encoding like this. James gets replaced with 0, Johnson gets replaced with 1, Jackson gets replaced with 2, and Juergens gets replaced with 3. The machine learning algorithms will look for a relationship between the target that we're trying to predict and an increasing value of this feature. But increasing probably isn't a concept that makes sense here. There's really no reason to think that Johnson is greater or more than James, or that there's any greater or less than relationship. So ordinal encoding can actually be dangerous if used in this way. Suppose that you're using ordinal encoding to determine, suppose you're trying to determine whether a loan application should be accepted or rejected, and you use ordinal encoding on the city that the applicant lives in. Is one city greater than another? If you use ordinal encoding, you're saying yes, and you're telling your machine learning algorithm to look for greater city values. And that not only doesn't make sense, it could also introduce bias. On the other hand, there are instances where ordinal encoding makes sense. Since if you look at the mushroom data set feature, there are several where it seems to make sense that they would actually go in a line. Ring number, which appeared to us as a categorical variable, there's actually a lurking numerical variable. So in this instance, replacing none with 0, 1 with 1, and 2 with 2 makes perfect sense. I'm certainly no expert on mushrooms. In reading this, it also looks to me like this population variable might be naturally ordered, because as I go from abundant to clustered to numerous to scattered to several to solitary, that seems to be like there's an order on the variable as where it's becoming less abundant or less populated as we move into the different values. Ordinal encoding can be a valid technique, but just be careful that you're not using it in a way that can be misrepresentative of the data that you're working with.